In this question, we are given that there are 8 identical triangular pieces of cardboard which were used to form a square and a rectangle respectively. We have to find the ratio of the perimeter of x to the perimeter of y. The only information that is given in the question is that all the triangular pieces are identical. Now, let's move on to step 2 and understand the methodology. If we consider just one part of the square, we know that the diagonals of a square bisect at 90 degrees. Let us name this triangle as A, B and C and assume the length of AB to be equal to A. So AB is equal to A implies that BC will also be equal to A since it is a square and the diagonals bisect each other. If we redraw the triangle ABC, we get that the hypotenuse is unknown and BC and AC is equal to A. So we can find the hypotenuse AC, which will be equal to root over of A squared plus A squared, which equals root over of 2A squared or root 2A. So the length of AC is equal to root 2A. Now since this is a square, the perimeter of square, that is the perimeter of x, will be 4 times the side. Now if we use the same variables for the rectangle y, then the length of triangle, then in triangle DEF, the length of EF will be equal to root 2A and ED and FD will both be equal to A. So the length of rectangle will be equal to 2 times A and the width of rectangle will be equal to A. And the perimeter of a rectangle, that is the perimeter of y, will be given by 2 times length plus width. Substituting the values of the perimeter, we can find the ratio of perimeter of x to the perimeter of y. So the ratio of x is to y will be equal to 4 times root 2a divided by 2 times 2a plus a. This equals 4 times root 2a, 2 times 3a. Now 2 cancels 4 2 times and a gets cancelled from the numerator and denominator. So the required ratio of x is to y, which is the option C.